Okay, question number 11. We're going to go 11 through 16. This is the EOCT study guide. Um, okay, so for number 11, it's asking you to compare the different pulse rates in the class. Now, the thing that you need to remember is with a box and whisker plot. I always put hashtags at the, or little hash marks at the end, not hashtags. They put dots. It doesn't matter. It means the same thing. Okay? And then let's just say you've got a box. And the box will always have a vertical line down through it. Okay? What this means is this is your lowest 25%, or your lowest quarter of, in this case, it would be kids in the class. Okay? And this is your highest. And the box in the middle represents your middle half, or your middle 50%. Okay? So if you are trying to figure out which class generally has the highest pulse rates, you're going to do it kind of by imagining some vertical lines. So let me just do this right here. Okay? If I was looking right here, and I chose this location because I can see that my Q, there we go, move. Class 3 has a Q1, or the lowest quarter, happens right there, and I'm looking for the high end. Remember, it said it wants the highest, basically the highest, not blood pressure, it's pulse rate. Okay, class 3, 75% of them are above that. Okay, and here it's not even 50, because 50 happens at this line in class 2. So less than 50% is above that line. Here it's actually less than 25%, because this represents the top quarter right there. Okay, so less than 25% is above here, and here slightly more than 50, because the 50 is from this line on class 4, but that would represent 75%, and so this is less than 75% is above. You're looking for the one that has the most above that, and it would be 75. Okay? And so the answer is class 3, C, 75. Now I want to quickly kind of talk to you about something. It asked me for the highest pulse rate. Okay? So what I did was I found on here the Q1. I'm looking for the highest. If you're looking for the highest, you go to the low end. Okay? Because you want things to bunch above that. Okay? You go to the highest low end. Okay? If it was looking for the lowest, okay, I would go to the lowest high end. So I would go to the lowest Q3. Okay? And this is Q1. So just so you know, if it wanted to know in general which one had the lowest blood pressure, I would go to the lowest Q3, because that tells me the one that has a full, and I'm going to have to just shift it just a little bit, a full 75%, okay, of them are above. And I can see that this is 75%, 75% are below. Okay, here it's less than 75% are below. Here it's less than 25% are below. And here it's, let's see, it's also less, it's a little bit more, that's less than 50, because 50 happens here, and it's not quite 50. So if it wanted to know which class in general had the lowest pulse rate, it would be the one, class 1, okay? But that's not what it asked for, but I just kind of wanted to talk to you about, if it wants the lowest and you're looking at box and whiskers, you're looking at Q1 or Q3, okay? And if it says which one is the lowest, you're going to choose Q3 to look at, because you want to see things bunched on the other side. All right, so let's move forward to the next problem, number 12. The first is in the sequence is -1, and it wants to know which one represents the sequence. Notice the notation. I can tell because it's a sub n and a sub n minus 1 that this is recursive. Okay, now this is how you can say it. A sub n means this one. And by that I mean whichever one you're looking at. Okay, this one and this one means the one before it. The minus 1 subtracts you backwards before. Okay, so if you see a sub n equals a sub n minus 1 plus 1, instead of saying it that way, say this one equals the one before it minus 1. That's what that means, okay? But I don't know what the answer is yet, but I just want you to interpret a sub n means this one, and a sub n minus 1 means the one before it. So let's see what's happening here. From negative 1 to 1, I went up 2. From 1 to 3, I went up 2. From 3 to 5, I went up 2. And from 5 to 7, I went up 2. I'm going up 2 every time, okay? So this one equals, so like let's just say you started here. This one equals the one before it plus 2. And that's it. The answer is B. Okay? Moving forward. This is another sequence. Let me erase this stuff. This is another sequence, but you can look at the notation. It isn't written in recursive notation. It's written in a different notation. It's just written in functional notation. And n just represents like an x value, except they're using n. So it's just a little bit more confusing. Basically, it's functional notation, but it's definitely written as a sequence. A sequence, the difference between a sequence and a function is generally that a sequence doesn't use like 1.5. It doesn't use numbers in between 1 and 2. Okay? So this is saying this function, this functional sequence, it wants to know what's happening. Well, from 6 to 18, I know that I went up 12, but I can see that that's not what that is. Actually, I multiplied by 3. From 18 to 54, and you can use your calculator to figure this out, that's times 3. This is times 3, and this is times 3. Okay? So all of these are times 3, which means the base of your exponent, if you repeatedly multiply by 3, that means that it's looking like this over and over and over, which means this is the base of your exponent. Okay? Now, here C has a base of 6. That's not it. B has a base of 6. That's not it. Okay? So now all we have to look at is, what is this? Well, it's going to be 3 to some power. Okay? Here's the thing. If you start at 1 in a sequence, okay, the outer multiplier is always whatever the value is. And so 6, that's this initial value right here, goes right here in front of the repeated multiplier. Okay? Now, in function notation, you always do n minus 1. Okay? So the answer is 6 times 3 to the n minus 1 power. And you can just check it by plugging the answers in and see if you come up with what I'm talking about, which you would. Okay? So number 13, excuse me, is D. Next one, number 14. Which function is modeled in this table? Looking at this table, first of all, I want to make sure that my x's are traveling at a constant rate. I'm going up 1, up 1, up 1, correct? Now then I look at my y's, I went up 8 plus 8 goes up 3 to go to 11, and then up another 3, and then up another 3. All right, that means your slope is rise over run, so 3 over 1 or 3 is slope. Your starting point generally is where the 0 is. You can do it a couple of different ways. I personally just go backwards because I'm already at 1. If I went up 3 from the previous number, what was it before it was 8? And that would be 5. So that means B, which happens at 0, okay, is 5. So this equation is y equals 3x plus 5. 3x plus 5 happens at D, and there's your answer. Next problem is number 15. The first term in the sequence is 3. Which function represents the sequence? Okay, this is written in function notation. Looking at this, 3 to 10, I went up 7. 10 to 17, I went up 7. 17 to 24, I went up 7. Clearly, my slope is 7, okay? And notice that's up 1, up 1, up 1, so it's 7 over 1, or 7, okay? All right, and here's the thing. Remember that if you're given this chart like this, okay, just imagine what would it have been at 0, okay? If you went up 3, oh no, excuse me, up 7, up 7, up 7, okay, every single time. What would it have been before 3 if to get to it you went up 7? And hopefully you know on the number line, okay, if you end at 3 and you have to go back, here's 0, okay, and you have to go back 7, 1, 2, 3, 4, 5, 6, 7, that would be -1, -2, -3, -4. You would be at -4. So the answer is, so the B is -4, which means the equation is y equals 7x minus 4, or in this case, f of n equals 7n minus 4. And that would be B. So number 15 is definitely B. And that's your numbers 11 through 15. So good luck with the rest of your test.